guys, welcome back. In this video we are going to talk about IP addressing. So basically, what is IP address? IP addresses are mainly used to identify your device in a network. For example, let's say you have a house. So your house has an address to uniquely identify your house. So someone posted some letter to your house saying your address. The postman can easily find your house using this unique address. Likewise, in the internet, we use IP addresses for uniquely identify a device in a network. So basically, IP addresses we can divide it into main two categories. So according to different criteria, we can divide into more categories. So basically, in this part, I am talking about versions of IP addresses. So we can find two versions of IP addresses. First one is IP version 4, which is old IP version, and IP version 6, which is the new IP version. In modern day, we are using IPv6 IP addresses to access the internet. So IPv4 is almost going to over the amount of IP addresses that we can provide to our host machines. So we have to introduce new IP version to give more IP addresses to on demand. So but still we are using IPv4 addresses for make subnettings and make private networks in our systems. So it is important to know, and it is easy to study IPv4 version IP addresses here. So in this video, I'm focusing on IPv4 IP addresses, how they can behave, how we can use them for subnettings, like kind of stuffs. So let's move on to our content. So when we considering both IP version 4 and IP version 6 addresses, there are some differences to identify. So when we consider an example of IPv4 IP address, we can say 192.186.1.10. It is an example for IP version 4 address. So in this IP address, we can see there are, so this is one slot, this is the another one, and this is the another one, and this is the another one. So the main thing is this is separated from a dot symbol. So we call this notation as dotted decimal format. So when we considering this IP address basically contains 32 bits for this IP address. We divide this 32 bits into 4 groups of 8 bits. So 8-bit slot represent the one slot like this. So basically 192 represent in 8 bits, 168 represented in 8 bits, and 1 represented in 8 bit, and 10 represented in 8 bits. So convert this IP address into binary format, it will appear as this. So this is how the IP address is represented as decimal format represent in binary format. So this slot stand for 192. We know we can convert this decimal into binary format, and after converting binary format, 192 represent as this. So we have to keep in mind every number between two dots we have to represent in 8 of bits. So this is stand for 168, this is stand for 1, this represents 10. So this is how the IP address actually represent in binary format. So we can see this in decimal format in our computers. This is the main thing we have to getting know about IPv4 addresses. So one thing we have to know about this IP address, that is what are the maximum and minimum values that one slot can contain. So this one slot can be minimum of 0 and maximum of 255. So how can we say with this is the minimum number and this is the maximum number? So we can calculate this one. So we have 8 bits here, 1 2 3 4 5 6 7 8, and if we want to calculate the minimum value of the, minimum value that we can represent using this 8 bits, we can simply put all of these bits as 0. After putting those zeros, if we convert this into decimal format, we can get 0 as our minimal value. So if we want to calculate maximum number that we can store using 8 bits, we can simply put 1 for all the bits. So if we consider this into decimal format, we know this positional value is 1, this is 2, this is 4, 8, 16, 32, 64, and this is 128. So if we add those numbers together, we can get 255 as our result. So in here we can only store numbers between 0 and 255 in a one slot. We have to remember this clearly. Okay, let's take the same example that we discussed previous. So when we considering an IP address, we can have two parts of this IP address. So when we draw the IP address like this, there are two parts. This is one part and this is one part. The left hand side, we called it as net IP. Basically it is network IP, and we simply say net IP, network IP, and this part is called host IP. That means the part in the left side we take for identify the network. We identify what is the network we are currently in, and the right hand side part we use to give IP addresses to our host machines. So these are the main two parts that we can divide the IP address. So if I write the subnet mask of this IP address, it contains the all the bits in here as ones, all the bits. Let's say this is divided after 24. So all the bits in left hand side, or let's say all the bits before 24 are ones, and all the bits after 24 are zeros. So basically the subnet mask says what are the bits that we can use to divide host. It indicates what are the bits that we use for our network. So this part is this part indicates this these bits are used for our network, and this part, this host IP part, indicates okay, you can use these bits for your host machines. So when we go talking about subnetting, and when we divide them into subnets, we can use only host IP range for make our subnets. So Other all ones are going to our network part. According to these conditions, there are 5 main categories that we can divide the IP addresses. So let's dive into it. Okay, let's talk about these 5 categories of IP addresses. So if we take these classes, we can see we are using class A, class B and class C for our networking purposes. So let's take a look about class A IP address. So we have basically 4 parts. This is the first part, this is the second part, this is the third part, and this is the fourth part. So if we consider about this block, we are only use this block for network ID. We call net ID for our networking purposes. So in class A IP addresses, bits in position 8 to 32 we can use for our host IP addresses. So basically we can find our class A IP addresses. So let's say you are given IP address and you have to find what is the class of this IP address. It is very important to know what is the IP address, because we are going to make subnets using this IP address. We have to know what are the host IPs that we can use for our subnet purpose. So if you are given a IP address, you can simply find whether it is class A IP address by looking at the first digit of the IP address. So that means if you given a IP address in decimal format, you have to convert it into binary format and see whether the first bit of the IP address is 0 or not. And we can easily find by remembering the range of class A IP address like this. So the range of IP address in class A is 1 to 126. If the first block of IP address contain 1 to 126 range, that means it is a class A IP address. So we can use these all host IDs to our subnetting purposes. So we can use 2 to the power, this is 8 bits, this is 8 bits, and this is 8 bits. So together there are 24 bits. So 2 to the power 24 addresses to our subnet purposes using one IP address. So this is a very large amount of IP addresses. So class A is used for very large number of networks. So when we move on to class B IP addresses, we can basically find class B IP address by looking at first 2 digits of the binary format. The binary format of the IP address starting with 1 and 0, we can simply say it is class B IP address. So another way to identify the class B IP address, we can remember it is in range of 128 to 191. So this is the range of class B IP addresses. So if the given IP address contains a number between 128 and 191 as the first block of the IP address, we can simply say this is a class B IP address. So the class B IP address basically use this range to network purposes. So it takes first 16 bits to network IDs. So other 16 bits allow us to make our networks. So we can create 2 to the power 16 different IP addresses using one network ID. So this is a very less amount with considering class A IP addresses, but it is fine for in middle size networks. So when we move on to class C, we can identify by looking at these first 3 digits of the class C IP addresses. That means if the binary format of the IP address contains 110 as its first 3 digits, we can simply say, okay, this is class C IP address. So class C IP addresses use first 24 bits for network purposes. It allows only 8 bits to make our host. So we can simply identify what are the IP addresses in class C. So it start at 192 to 223. So range between 192 to 223 means that is class C IP address. So using class C IP address, we can create 2 to the power 8 different IP addresses. So that means 256. 256 IP addresses we can create using one network ID in class C IP addresses. So these 3 are the main classes of IP addresses that we use for our networking purposes, and these 2 parts is dedicated for some experimented purposes, class E, and multi-class group addressing for class D. So class D and E addresses we don't go to use for our networking purposes. We only use class A, B and C IP addresses. So for more information, I will say what are the ranges of this class D and class E IP addresses. So class D IP addresses contain 224 to 239, and class E IP addresses contain 240 to 255. So these are the ranges of classes. So we have to keep those in mind to identify whether the given IP address is class A, B, C, O and whatever else. So the special thing there for focus, can you see, so class A IP addresses contain 1 to 126 range, and the class B IP addresses started with 122 to 191. And if you compare class B and C, you can see it's class B end with 191 and class C start with 192. But when we considering class A and class B, class A end up with 126, but class B started with 128. The 127 range that start, the IP address range start with 127 is not there. Why we don't mention it here? So the IP range that start with 127 is a dedicated range for the testing purposes, so checking purposes. So we have special IP addresses called 127.0.0.1 is normally called as loopback IP address. So this is basically used for our testing purposes of the system. So right, these are the main components that we have to know when we are looking about IP classes. So that is very important to identify what are the classes that we can found in these IP addresses. So let's move on to our next part. So the next part that we have to discuss is network addresses and broadcast addresses. When we have a network, all the network contains a network address and a broadcast address. So let's see, we have a network with three terminals. So we have three terminals in our network. These three are connected like this. Imagine this is a network we only contain these three machines here. So let's see, network those computers using normal IP addresses. So let's say we take 195 172 5.1, right? This is a random IP address that assigned for this terminal. Let's imagine this is the IP address of this computer. So this is 195 and 172 5.2. This is 195 172 5.3. These are the three computers that we can found in this network. So these three computers are visible to the internet because these are using public IP addresses. Let's discuss them on a few minutes later. So let's say these three machines contains these IP addresses. So the thing is, the network address of this network is the very first IP address of this network. This is a class C IP address. So you know there are floor blocks containing 8 bits for each block, and we know first 24 bits are used for network addresses. So we cannot use these three addresses, these four IDs for our host IDs. So this is the only one we can use host IDs. That's why I don't change this part. I only change the last ID of the IP address. So these three are same for these three terminals. That's why I can say these three computers are in the same network. So when some computers in a network contain same network ID, we can say these three computers are in same network, or that they have to be connected to each other. After that, we can say if the network ID is same for all computers, these all computers are in the same network. So only the host ID part is differentiated, and keep in mind there cannot be two terminals with the same IP address in the same network. So different network it can find, but in same network we cannot have terminals with same IP addresses. So when we consider in public IP addresses, we cannot find anyone in the world that contains same IP address in others, but when we consider in private IP addresses, this will be fine. So let's take a deep look about public and IP addresses little bit later. So in here I want to focus about the very first IP address of the network we considered as network address. So keep in mind, if you ask what is the network address, it is the very first IP address of the network. How we can find it? So we cannot change these three blocks, so we have to fill this with the same values because they didn't change. So only the part we can change is this one. So this one contains 8 bits. The very first IP address of the network is the address that contain all zeros of the network. So when we put all zeros for this host ID, we can get the decimal result as 0. So the 0 is the first most IP address we can find in this network. So in this IP address range, so this network, we can say network address is 192 sorry 195 172 5.0. This is the network address of this network. So if we want to calculate what is the broadcast IP address, the broadcast IP address is the last IP address of the network. So if we want to calculate the last IP address of the network, we can simply put 1 for all the IP addresses, sorry, all the bits of that block. So if we convert this into decimal, it gives us 255. So the broadcast IP address of this network is 195 172 5.255. This is the broadcast IP of this network. So we are using class C IP addresses. So according to this, we can conclude the network IP address of class C IP address range. This is the network IP address of this network, and this is the broadcast IP address of this network. Okay, now we discussed what is the network network address and broadcast address of a network, but we didn't discuss why we need network address and broadcast IP address for a network. So purpose of network address is uniquely identify the network in our system. So in our company or our organization, in organization there are a lot of networks. There can be different networks for different departments. In all the departments are connected to one point or one router to access to the internet or any other services. So when we routing data with those networks, we have to identify what is the network, and we have to we should have a way to identify what is the network. So for that purpose, we use network address to uniquely identify the network, and we cannot assign this network address to any other terminal. And the broadcast IP address is used to send a broadcast message to every node in the network, and it is the last IP address of the system. So this is the usage of network address and broadcast address of a network. Okay, now move on to topic of public IP addresses and private IP addresses. Okay, let's talk about public IP addresses and private IP addresses. So after release IP addressing, there are no two types called public IP addresses and private IP addresses. So the reason for coming private IP addresses, we have to make our private networks. The demand for IP addresses goes very high, and the IP addresses become over rapidly due to high demand for IP addresses. So because of that, people think if we assign a public IP address for a local area network, it will be a waste of IP addresses. So that they introduced two different type of IP addresses called public IP addresses and private IP addresses. The difference between public IP addresses and private IP addresses: the public IP addresses can access all the resources in the internet, so it is publicly available and everybody can see the IP address. But the private IP addresses are didn't expose to the internet or others. They remain as internal IP addresses of a particular local area network or what kind of network. So if the terminal in a private network or local area network want to access the internet or want to access some resource in the internet, the machine has to go through a public IP addresses. So that these processes will be discussed later, how to uh, find a public IP address in from a machine in local area network. But the idea is the all the machines in a local area network uh, goes to the internet using only one public IP addresses which is assigned to that particular router. So other computers are work with private IP addresses. So if we have networks, two networks like this is our network 1 and this is network 2. Imagine there is a PC contain 192.168 and 0.10, like this IP address, and there can be another terminal 192.168.10.0 in different local area network which is created using private IP addresses. There can be same IP addresses in different networks. There can be same private IP addresses in different local area networks, but in a same network there cannot be the IP address with same ID. So I think the idea is clear, what is private IP addresses and what is public IP addresses. So in upcoming videos you will learn how to use these together to achieve a successful network architecture. So when we considering about private IP range, so basically they introduce three types of private IP addresses for the our main classes we use to network. So for class A IP addresses, they introduce the IP range for 10.0.0.0 to 10.25.225, so 255 to 255.255. This range is assigned, we can use as class A IP addresses, and they introduce this for class B range, and they assign this for class C range. So you have to keep in mind what are the ranges that we can use for our private IP addresses. So even I say this is for class A, class B and class C, we have to keep in mind the private IP means classless IP addresses. So we can say those have the correct class, but it is fine, and we can simply get idea those are for class A, B and C. It will help for our calculations in upcoming videos. So here we talk little bit about subnetting. So why we need subnetting? If all of us in a public network, we cannot maintain our routing purposes clearly, because of there are millions of terminals in our network. So if we can divide our networks into small parts, it will help to manage our complex routing purposes. So it will reduce our complex routing purposes because there are limited PCs or nodes in the one network. So it is very helpful advantage in subnetting. And it will distribute the network load for different networks. So if we all are in one network, the load of network is very high. So if we can divide that network into small subnets, will distribute the load of network for all these subnets. So it is another good advantage when we are using subnetting. So when we are going to talk about subnetting, it is important to know about uh, subnet mask. We discussed little bit about subnet mask first part of this video, but here we discuss deeply what is subnet mask. So when we considering the classes of IPv4 addresses, we basically use class A, class B, and class C for IP addressing purposes. So let's say there is a IP address in class A. So class A IP address, we know basically use first 8 bits for our network IP, network ID. These are net IDs, and other 24 bits are host IDs. So if we consider about subnet mask of this class A IP address is 255.0.0.0. Why I say the subnet mask of this IP address is 255.0.0.0? The first part of the IP address is net ID, and I said you the net ID part is not will change. The only the part will change is host ID part. So the subnet mask indicates that what are the range that you can use for networking, and what are the parts that you have to use to net ID part. So that differentiation will indicate using subnet mask. So if we have subnet mask like this, it indicates this first part you cannot use and these three part you can use. So let's talk about how this one derived. So let's say we have IP address of class A. So this class A IP address, if I draw the bit pattern of this, the first one is like this, so other one is like this, and other one is like this, and other one is like this. So let's say all are 8 bits. Okay, so we know that we cannot use these first 8 bits for class A IP address, so we have to mark all those as 1 because we cannot use these IP addresses, right? So because we cannot use all the 8 bits for networking purposes, we mark those as ones. So other all 24 bits we can use for networking purposes, so we can mark all of these as zeros. So after converting these binary pattern into decimal format, we can derive the value that I written previously, 255.0.0.0. This is the way that we can derive the subnet mask of a particular IP address. So this is the subnet mask of class A IP address. If we consider about class B IP address, so we know first 16 bits used for net ID and other 16 bits used for host IP. first 16 bits for net IP and 16 bits for host ID. So in here, if we write the subnet mask of class B IP address, the first 8 bits we cannot use, so we can indicate it as 255, and the second 8 bit we cannot use, so we can indicate it also as 255, and we can use other 20 other 16 bits, so we can mark it this 8 bit as 0 and this 8 bit as 0. So basically the subnet mask indicates what are the IDs you can use for host and what are the IDs that you can use for network. So finally, if we consider about class C IP address, 8 bits for host and 24 bits for network. So now you can imagine what will be the subnet mask of this network. So first 8 bits is for network, so we cannot use it, so I will indicate it as 255, and second bit also 255 because we cannot use it, and third bit set is also 255 because we cannot use this, and only the part that we can use is this, so we can indicate this as 0. So the subnet mask of the type C IP address is 255.255.0. So this is the basic subnet mask that we can assign for class A, class B and class C IP address if we are not subnetting. Okay, if we are going to subnetting, this default subnet mask will be changed. So basically this is the idea about default subnet mask of the class A, class B and class C, which is we mostly use for networking purposes. So there is one thing to be know, that is there are 4 different types that we can indicate subnet mask of a particular IP address. So we can write subnet mask of a IP address like this: 255.255.0. That means the way I write here, it means that we called it as dotted decimal format. So another way we can write this as binary format. This is that way. We can simply write it as like this. So this is the format we can use for indicate subnet mask of IP address. We call this method as binary format. So we can use it as dotted decimal format, and we can indicate it as binary format. And there is another way we can say bit count to network IP address. So let's say we use 8 bits for this class A IP address, so we can say this subnet mask is 8, and we use 16 bits for network, and the subnet mask of class B is 16, and we use 24 bits for our network, and subnet mask of class C is 24. This means the bit count. So we also call this as CIDR, which stand for classless interdomain routing. So this notation is called as CIDR notation as well. So CIDR stand for classless interdomain routing. So there is another way to indicate this. So this is not commonly used for indicating subnet mask of an IP address, so we can define this as a hexadecimal format. So we can write this subnet mask as like this. So the same subnet mask 255.255.255.0, we can write it as 4 different ways. So most commonly used notations are first one and the third one. So other two will not commonly used, but we can indicate the subnet mask as this. So this is about subnet mask. So we will discuss how to calculate the subnet mask of when we subnetting a network. It is very important to know. So there are some small concepts to discuss before moving to some problems. So the other thing we have to discuss is ClassFull addresses and ClassLess IP addresses. So we have two different type of ClassFull and ClassLess. So what mean by ClassFull and ClassLess? So let's say there is an IP address called 10.0.0.0 and its subnet mask is 8. So there is another IP address 10.0.0.0, but its subnet mask is 16. So the idea of ClassFull IP address is it is using the default subnet mask of its class. Let's say this IP address that is starting from 10 is used for class A IP addresses. Class A default subnet mask is 8. So in the example in left hand side, use the subnet mask 8. So the IP address use the default subnet mask of the class. So the example in right hand side, it not use default subnet mask of the class. It says you can only use other 16 bits, you cannot use first 16 bit because it is used for network ID. So this means this is a classless IP address. So the IP address in left hand side is known as ClassFull IP address, and the IP address in right hand side known as classless IP address. So let's take some examples. 176.16.0.0. So we can say this the subnet mask of this IP address is 16, and for same IP address one say no, your subnet mask is 24. So the example in left hand side use the default subnet mask of the IP address because the IP address is class B IP address. So the example in right hand side use the another subnet mask rather than default subnet mask. So it is a classless IP address. So let's take one more example. 192.168.1.0/24. So this is class C IP address. So we can say the default IP address, default subnet mask of this IP address is 24. So the 192.168.1.0, this is use 28 as its subnet mask. So it didn't use the default class C subnet mask, so we can consider it as classless less IP address. So I hope you can clear what is class full IP address and classless IP address. Okay, let's consider about network address translation. So network address translation means, so when we are in a private IP network, we want to access the internet. So when we going to access the internet, we have a public IP address. So the connecting this private IP to a network public IP or connecting different network, this process is called network network address translation. So for network address translation is occurs inside the router. So let's say we have a PC1. So PC1 release a data packet called P, and it contains an header. This is the header. The header file of this data packet contain the IP address, destination IP address, destination MAC address, in starting IP address, starting MAC address. So likewise many details include in this header files for different included from different layers of the ISO model. So imagine the IP address of this PC is 192.168.1.1. So let's say subnet mask of this IP address is 24. So after generating a data packet from this PC1, the header file appears like this. So it contains the source IP. So source IP is the address of the current PC, 192.168.1.1, and it contains the destination IP. So how we can find the destination IP of uh, the current packet? So for that we have to know about something. So when we considering about router, it contains two sides. So this is one side and this is another side. So the thing is, the one side behave uh, in a different network and other side behave in another different network. So if we consider the this side of the router, it should be in same network with PC1. So its IP address should be 192.168.1 and something. So let's assume it is 5. So it can be something, so we assign it 5. So the other side of the router should have a public IP address. So let's say the IP address of that packet is 202.107.1.16, like this. So when the packet transmitted to internet, it should go through this router. So the source IP of the data packet is this IP of PC1. Let's say we want to transmit the data packet to a PC in the internet containing IP address 200 7 172 1.20, like this, right? So what we have to do is the data packet mark the destination IP address as we want. So it changed the destination IP of our transmission data packet as 207.172.1.20, which is our original destination IP address. So after this data packet reach to the router edits the source IP address as its another side IP address, which means, let's say this is the data packet we send from PC1 and this is the header of it. After getting this to the router, it change its source IP address as 202.107.1.60, and it contains the destination IP as same as previous. So 107.172.1.20. So if let's assume the data packet will transmit directly to the PC that we want to send message from the router. So when the packet reaches to the our destination PC, it can see the source IP as full. So it cannot see the source IP as the PC1 IP, but it can see the source IP as the IP contains the router. So when the packet transmitted from the PC1, the process of changing the source IP is when we go through those routers, we simply call it as network address translation. So what it will done is it basically change the source IP of the interface of the router it passed. So this is the basic idea of network address translation. So that's it for this video. We'll discuss those kind of stuff on upcoming videos as well with more details. So stay tuned. Thank you.